System Administration Section 2, Configuration and Tuning. As I mentioned, we use static plugins for our configuration of dotCMS. It's a little large. So when you unpack a dotCMS install, you have a number of folders. The first being the bin folder, which contains all of the scripts that run various components for dotCMS: startup, shutdown. If you're going to build a WAR file, if you're going to build or deploy plugins or undeploy plugins, those scripts all exist in the bin file. It's important to know because as you go into customizing your dotCMS instance, one of the first things you're going to want to change is your startup script, because the startup script is where we declare how much memory is allocated to this instance. And chances are you're going to want to change that. In a development environment, you can probably use the default. Once you get past that, you're probably going to want to increase the memory. There's a docs folder, which contains the documentation. And the core of it is the dotCMS application server. So within this, we have our Tomcat folder. We have everything underneath that, including logs. Where we want to do our configuration is here in the plugins folder. It is a lot easier to keep track of changes that have been made. It's a lot easier to spin up new environments based on an existing environment. It's a lot easier to do backups and restores if you do your configuration through a plugin. If you're making changes here in the dotCMS application tree, keeping track of those is a lot harder. And doing any changes, like if you want to deploy an upgrade to dotCMS, you have to track down every single file that's been changed in that tree. Whereas if you do things through the plugins folder, you simply have to redeploy your plugins in the new environment. If you're if you're upgrading from like 4 to 5, there are some changes you'll need to make before doing that, but we'll talk about that when we talk about upgrades. So what static plugins do is they allow custom development to happen in dotCMS without permanently modifying the core dotCMS code. So you can run a stable release version and still be able to add or modify custom logic without breaking any upgrades and without irreversibly making changes to dotCMS. So they provide a way of developing some new functionality on top of your existing instance. It also allows you to override existing functionality. So it's a bit more modular and portable, as I said, when you're going to move from environment to environment, or if you're going to do upgrades or if you're going to do restores. So the typical static plugins are used to override the default configuration. We configure dotCMS out of the box to be a sane setup for a development environment. Before you move into a production environment, you will have changes you're going to want to make. The settings that we set as our defaults are not the ones we would use in a production environment. When you make changes in your plugins, and I don't have expanded there, but I'll go into my plugins folder here. Oops. So go to my plugins folder here. In this com.cms config is the default plugin that's included with all .cms releases. And it has a basically mirrors the structure of the application server. You've got a conf folder, you've got a JSP folder, you've got a lib folder. There's an extra folder in here called root, which we'll talk about in a minute. So you're going to do most of your configurations probably in this conf folder to start with. There are a few things that will have to be done in the root. The difference between doing something in the general plugin tree and the root part of the plugin tree is the way that the plugin deployment will process those. Something here in the conf folder, it's going to look for a comparable file here in the application tree and apply your changes to that file. Things in the root folder are things that you want to completely overwrite and not risk having duplicates set. So things like your database connector, things like your startup script. We're going to put those under the root of the plugin. So when you set a property in a plugin, dotCMS will use your value, even if that value is already set in the dotCMS core. It's also true for Java code. If you have any Java code in your plugin will come first in the class loader. So if you are using the same classes, if you're overriding a dotCMS class, if you're making changes to it, they'll be picked up first. So if we go into this conf folder, we'll talk about a couple of the basic configurations that we do in a typical dotCMS instance. By default, there are 2 files in here. The first being the config cluster, which we'll talk about in a minute when we go over cluster configuration. The first one we're going to talk about is the .marketing config. So there are a number of things you can set in here. The first and most common one is this asset real path here, which is the path to the actual assets folder that I talked about earlier in this diagram, this assets folder here. You're going to set that asset real path. Where are we putting our assets? Are we putting them in a separate partition because we're worried about disk space? As you're setting up instances, that's one of the things you have to think about is disk space. We will typically put the dotCMS install itself on a fairly small partition because it's not going to change a lot if you've moved your assets and moved your dynamic content, your index and your cache off different partitions. The one other exception being log files, because log files can grow a tremendous amount. And the reason we will do this is because if you fill up a partition and on that a Java application is using, that Java application will crash. It can't write to disk anymore. It's going to crash. So moving these onto their own partitions, you could run out of disk space on your log partition. You could run out of disk space on your assets partition, and they will cause some troubles, but they won't crash dotCMS. Now, if you run out of disk space on your dynamic content partition, it will crash dotCMS, and I'll talk about that a bit more in a minute. So a couple of the other things that will typically change here in this file, we would change our dynamic content path, which is the path to this index and this cache. In my training environment, I haven't done that just because it's not an environment that gets heavy use. It's not really necessary, but that is generally considered a best practice. There is a setting called force captcha. It is by default, it's set to true. You can set it to false if you're using some other captcha alternative and you don't want to use the built-in one. A couple of settings that I strongly recommend turning on in a development environment, but not turning on in a production environment due to both security and performance, are show velocity files. What this does is here in your assets folder, every page here is composed of a bunch of different files, a bunch of different pieces of content that are all wrapped together in a template. And when you're trying to debug things, that can get difficult to track down. Is the problem happening in this include? Is it happening in that include? Where's the problem? What this setting does is it will write out the full template for each page as it gets hit into this assets folder. So if you come into the products page, then here in this folder, you'll get a single file that has the entirety of the pre-rendering code. So it's going to list all of the velocity calls. It's going to list all of the macros you're using. It's going to list out everything that's being used in that page before it gets rendered. which makes it a lot easier to try and debug any problems. There's also a log velocity templates, which just increases the logging level of velocity. Velocity already logs a lot. It's a pretty noisy system, so you can add to this if you're trying to debug something in a development environment. It can be pretty useful. There is clickstream tracking. So clickstream tracking is a real basic analytics tool. It's not intended for an enterprise site. It's not intended for a large install. It does a lot of database writes and can actually cause your database connections to become saturated if you have a lot of traffic. And it writes a lot to the log files, so it can use up a lot of disk space ultimately. If you're interested in analytics, the first place you start is Google Analytics, which you can use instead of Clickstream. So I generally am going to recommend turning off Clickstream tracking. And the final other common configuration you'll see in here is TinyMCE, where you simply provide a path to a TinyMCE configuration file. We have documentation on our site about what customizations you can make to the TinyMCE, which is the, we'll log in and take a look at it real quick. So if we go into some content, it's a little slow because this is the first time I've used this environment. So we come into the Bear Mountain Lodge. Now we don't have. That's new. If I look at it through the site view. Well, it does not look like I have TinyMCE actually configured in here for some reason. But the what you see is what you get toolbar when you're editing content in a web page is the TinyMCE configuration. I apologize. This is my first time working with our 5.0 release, so I am figuring it out as I go. So those are the basic things you'll set here in this conf file. And there's more you can do, and there's a lot more you can do in here. The basic dotCMS marketing config file runs to a couple of hundred lines of variables. But the idea behind doing it this way is you don't want to have to try and pour through that file and figure out what needs to change. Is you simply make your changes right here. And this ext tells the plugin build system, go find the .marketing config.properties, find these variables in this file, in that file, comment those out, and use the ones from this file instead. So it's pretty straightforward. As I said, the dotCMS config cluster we'll talk about in a minute when I talk about cluster configuration. As I mentioned before, you come into this root folder are the main things you're going to want to look at when you are setting up a new dotCMS instance. So the first thing you want to do is change your memory. So here under Java ops, where we're setting, in this case, our memory setting starts at 1 gig, which is not really all that much. Even in a development environment, 1 gig is a little bit less than what we generally are going to recommend. And these settings are starting points. Every environment is a little different. Every set of content is different. The complexity of your content, the complexity of your content structures, and the relationships between content all have an impact. And so it's hard to give an exact, this is how much memory you need to have. We have some guidelines here which are considered a starting point. If you're seeing problems with performance, then obviously that's when you look to increase it. As a general rule, we want to leave about maybe 30% of the memory for the operating system, and the rest allocated to dotCMS. You don't want to run into a situation where the operating system needs to do something and it can't find enough memory, so it looks for the object using the most memory, which is going to be Java, and kill it. I've seen that happen. I've seen it happen in production environments where people only left 5 or 10% memory for the operating system, and the operating system simply said, well, I'm more important than the Java application, so I'm going to kill the Java application so I can do what I need to do. And obviously at that point, dotCMS has crashed. So you view these as a starting point, view these as a general guideline, not as a hard and fast rule. But that's going to be set here in your startup script. You can make whatever changes you need to. We'll accept any standard Java ops for an application startup. If you're trying to do debugging, this is where you turn that on in a development environment. You would turn on this. You can turn on this for profiling. You can allow the YourKit Java profiler. Set your path to that. You can enable debugging here with the JMX remote port, so you can step through a process and see what's happening in your developer tools. So don't add any more. The next tool you're most frequently going to be adjusting is going to be, and if you're making changes to some of these core files in the root folder, you have to provide the full path to that file as it exists in the application. So in this case, we're going to go to .server Tomcat conf, and we're going to look at the server XML. If you're doing things like you're enabling SSL, you're changing what port dotCMS is going to be running on. By default, we're running on port 8080. In a production environment, we actively support Linux. Windows production server is a deprecated feature. It's something that's going to be going away eventually. We'll still support it right now, but it's on the chopping block at some point. In a Linux environment, it's not advised to run your applications as a privileged user, as a root user. So you have to run it on a port higher than 1000. Standard protocol for web applications seems to be hovering around port 8080, so that's what we use. We set our connection timeout. We set our redirect port for SSL. You can also set things like is secure in here, HTTP protocol type. There's a few other settings. Any standard Tomcat settings will work in here. This is a Tomcat instance. You can set your SSL in here. Our general approach in environments that we're responsible for is we will actually terminate SSL at the proxy server rather than in dotCMS itself. So we'll have a second connector, maybe on port 8082, to accept those SSL connections from the proxy server that aren't actually SSL at that point. But they are flagged as being secure connections. The next one we look at is under the web apps root metainf folder. This is the key one, the most important one besides the memory configuration. This is your database connection. So in here, we provide the syntax for your database connection. You simply drop in the URL for your database connection, your username and password, make any changes to it. As I was talking about with default settings, by default, we have max active of 60. So you can have 60 connections from dotCMS to your database at any given time. We recycle connections really fast. We try and close things as quickly as possible. So you can have a couple of hundred users on your website, but only be actively using maybe 100, 150 database connections. So you don't have to have the same amount, but you do have to make sure you have enough. 60 is probably not enough for a production environment. In a production environment, I generally like to start between 150 and 200, depending on how large or how much traffic you're expecting to have, and certainly goes up from there. You reach a point with Tomcat above 450 or so simultaneous database connections, where Tomcat performance starts to be a problem. And at that point, you want to start look at scaling out, adding more nodes into your cluster rather than trying to scale up. If you have a situation where you've got 450 database connections and you're seeing sluggish site performance because it's waiting for responses from the database, waiting to get those connections open up again, you're better off adding another node to the cluster than trying to throw more memory or more CPU at it, because chances are the database itself is not the bottleneck. It's rather that connection between Tomcat and the database. So we set those up here. We include all of the information to connect to the standard 4 databases we support. Out of the box, we actually have a local H2 database configured, so you can download and start up a dotCMS instance without doing any configuration at all, and it'll run. But it's not very performant. I wouldn't even run a developer workstation necessarily using it. And you can't move the data from place to place at all, really. You could create bundles and export them, but it's not going to be a great way to move data around from one environment to another. So that's the essentials of configuring your database connection, your server configuration, your startup script. And those are the most essential things you'll want to configure when you're setting up an instance. You get into a couple of other things, which I'll talk about in terms of authentication. I'll talk about those, I believe, either later today, possibly tomorrow. LDAP, SAML, OAuth, all those sorts of things. We don't get into a tremendous amount of detail about all of those, but I will discuss like how you would set those up and where you would set those up. But this is the essentials of getting an instance configured. Once you have an instance configured, it's up and running. You can log in. The first thing you're going to do is you've got some configuration. You'll probably change the image that's used on the background for the login page and the logo. You can change what language dotCMS is running in, change your time zone. Your authentication type, particularly if you're switching to an LDAP, particularly an Active Directory, you're most often going to be switching to user ID rather than email address. So be aware that this is where you would set that. Licensing. We've made a lot of changes to our licensing over the past few versions. I think it's a lot easier to deal with now than it used to be. To add a license, if you have a license text, you can simply apply it here. The most common approach is going to be if you have a license or a group of licenses, you're going to open a ticket requesting, I need 4 licenses for a cluster, or I need a single license for a development instance, you're going to get a zip file. You're going to upload that zip file. You choose your file, you upload it, and the contents of that zip file are going to show up here under the licenses. If you have a single instance, it'll just show a single license. You'll click that apply button. In this case, I've got a cluster, and it tells me this little lock icon, unlocked, says this server is currently using this license. I can free the license. Say I'm going to take this server out of commission and I want to free up the license for a new server I'm going to spin up. I would free it. A license that's not on this server, I can choose to apply it if it's available. If it's locked, I cannot apply it. But I can apply a license. I can also delete a license. And if there were enough out there, I would also have an option to free up a remote license. So those are all options that you can do in configuring your licensing. But once you have your instance up, particularly if you're pointing at a premium database like Oracle or Microsoft SQL, the first thing you'll have to do is apply a license. And you actually have to apply a license before you can add in certain kinds of authentication like LDAP. You can't set up LDAP until your instance is already licensed. So that's the next step of configuration, is getting your basic config and your licensing set up. You can come in here if you've got multiple instances. So you bring up your first instance, you upload your license pack, and then as you add your second dotCMS instance, you start it up. So I've got the second instance here, it's up and running. Am I on there? Am I on 38? So that's going to be 39. Oops. Okay. So it's already showing a Prime Edition license. And licensing, 65, etc. This is already licensed. When you add nodes to a cluster, if you have a license pack in the database already, as long as there are still free licenses, each new node that joins the cluster will automatically collect its own license. And we'll talk a little bit more about configuring a cluster in a minute. It can be very easy or very tedious depending on which approach you take. So the next thing you want to configure is going to be your cache. Your performance layer is something you're going to want to take a look at pretty early on, and something you're going to want to revisit a lot. Because as your traffic patterns change, as the usage of the application changes, that can impact how the cache is performing. So within that cache configuration, the first thing you're going to do is come and look at this cache page. So, okay, I've got a gig of memory allocated to this, or I've got a gig of memory set in my XMX. When Java starts up an application, it doesn't necessarily allocate all of the information right away. You can set it to by setting the XMS setting. And say XMX equals 5 gigs, XMS equals 5 gigs, and then you'll see the memory available and the memory allocated will be the same. Generally, you'll start up a dotCMS instance. It'll allocate as much memory as the JVM thinks it's going to need, and then it will allocate more memory as stuff starts getting used up. And garbage collection will affect how much is allocated, that sort of thing. The current amount of memory being used, and then the free memory is allocated minus filled. It's pretty straightforward. So that gives you a picture of, what does my memory situation look like here? Now, this is a point in time. You can look at this at several points throughout the day. And for instance, if this happens like during garbage collection versus after or before garbage collection, it can look a lot different. So it's important to look at it several times to get a real feel for what's actually happening here. So if we look into our stats, it breaks out the actual regions of cache, showing your on disk, the H22 cache, and your caffeine memory cache. It may be Guava memory cache if you're using a standalone instance versus caffeine if you're using a cluster. And so, because cache is a primary performance layer, you'll want to do some tuning early on, and then you'll probably keep an eye on it over time, particularly if people start complaining, saying, hey, we're getting some performance problems here. It seems like it's a little sluggish. You can come in and look at the cache layer and say, oh, okay, yeah, we have some problems here. We have some fine tuning we can do. For the on-disk cache, it's not as memory sensitive, obviously, because disks are pretty large compared to how much you're going to have in your cache. You can configure how many objects are going to be on the disk. We don't track things like evictions or hit rates or anything for the on-disk cache because it's rarely the problem. What you would want to do with the on-disk cache is just say, oh, this is a region, for example, out of the box, content-lit cache. This is a region that gets hit a lot. There's a lot of activity in here, and we don't want to lose all of that every time we have to restart dotCMS, because everything here in the memory cache, when you restart dotCMS, you lose all of that cache layer. It has to be rebuilt. Anything that's in the content-lit cache, you restart dotCMS, oh, well, it's already in the cache. It's on disk. It's saved. It survives restarts. So you might look at some regions and think, oh, this region would benefit from persisting across a restart. So that's really where the benefit of the on-disk cache is. It's also very useful for large things. You don't want a whole bunch of video files or PDFs or Excel spreadsheets using up a ton of your memory, of your in-memory cache, because that's not very efficient. You put them in your on-disk cache, and it's a lot better to manage that way. So when you're looking at the in-memory cache, first of all, it tells you, is it in the default region? The default region is a shared region. So all of these things that are marked as true are all living in a shared default region. You'll get better performance by moving things into their own declared region. So one thing you want to look for, if you have a region that seems like it's struggling, is it in the default or not? You'll help yourself by putting it in its own region. We look at the number of configured objects in that region versus the number of objects that are currently in that region. That's a pretty important metric there, because if you have a region, you think, oh, well, this region seems like it's struggling. It's allowed to have 100 objects in it, but it's only got one. Changing the settings on this region is not going to help you. You may need to look at, oh, well, does this need to be in the on-disk cache, or do we need to look at external caching for this, or is there something else we need to look at for this particular problem we're seeing? The next column here is the load. Load is the number of times that a cache lookup has been done to load a new value. It represents the amount of traffic on the website, essentially, for that particular region. The hits, which is a new metric on here, is the number of cache requests that are successful. The hit rate is the percentage of cache requests which are successful. So how often do we try and get something out of the cache and find it there? The higher the better. 100% hit rate, you can't get better than that. 99, you could get a little bit better. Probably not going to get a great benefit out of it, but you could get a little bit. You look at a hit rate of like 83%, there's a lot of room for improvement there. In this particular case, there's not, because we're not even close to our configured level. But again, this is a demo instance, doesn't get used for a lot. We calculate the load time average, and here there's not really anything. There's nothing in evictions. So I'm going to bring up a older cache stats example from a 4.0 installation. So it doesn't break out our memory the same way. Like here we've got our on disk and our in memory, and it's caffeine. Instead, this region shows everything mixed together. Here's some in memory, here's some on disk. And because it was a single instance, it's using the Guava cache, but the principles remain the same. So we can see in this instance, we've got 10 gigs of memory, 7 of which is currently allocated by the JVM to dotCMS, 3.6 of which is filled, 3.4 of which is available. So there's a lot of room to play with. To give you an example from today, have a customer who is looking at, they've got 8 gigs of memory, they've got 1.9 free, but they're not in production yet. This is just in their authoring region as they're getting ready to go live. And I look at that and I say, yeah, you've got a little bit of room for growth, but your traffic's going to skyrocket when you go to production. You need substantially more memory in this situation than you currently have. And then we go into looking at specific regions of cache and where we can make improvements. So we look down this list and we start looking for high eviction rates. We start looking for low hit rates. Low being a relative term. Like in here, we're looking at, again, 81%. We're nowhere near our configured amount. It's not going to be a big deal. Here, 96 seems like a pretty high amount, but then we see we've got 30,000 evictions. The load on the system is over 1 million. There's been over 1 million lookups to this cache region, and 30,000 times we did not find what we wanted in the cache. We're also maxed out. Configured memory and in memory are identical. This is a region that's going to benefit from increasing the cache. So we're going to say, okay, category parents cache, we should make this maybe 7,500, maybe more. Our hit rate's still pretty good. 7,500 would probably be enough for now, but it's open for discussion. We look at our content-lit cache, and content-lit cache is one that can almost always benefit from an increase in configuration. In this case, the hit rate is 86%. The evictions are 200,000, and that's pretty substantial. Or pardon me, 2 million. That's really substantial. We could probably double or triple. I've seen content-lit cache regions at 50,000, at 100,000, and still with hit rates in the low 90s. So that's how you determine really where you're going to benefit from improving the hit rates or improving the cache. Configuring it is remarkably simple. Let's go to node 2. So we're going to go to our plugins. We're going to go into config. And we're going to look at that marketing config plugin again. In this particular situation, because it's a cluster, we're going to want to make those changes on both nodes in the cluster. We don't want to just do one because you have different caches on different cache configurations on different nodes. You're going to end up with conflicts in the cache. So always make sure in a clustered environment you do all of the nodes. Configuring the cache itself is pretty straightforward. We simply declare cache category parents or cache.size. It's that simple. Really straightforward to declare the size. If you're wanting to go in and do cache chaining, it's a little more involved. So if you're chaining caches, you're saying we want it to be in, first of all, the in-memory cache, but then we want to fail over to to Redis, or we want to fail over to the on-disk cache. And so in that case, you would declare, okay, we want cache dot category parents. We're going to declare a chain. That chain is going to be provider class. So in the case of the in-memory, it's going to be, I think it's .marketing business cache. And then a comma, and then your next cache provider. So and so you could chain as many as you want to set up a cache chain. The hard part of cache configuration is figuring out what needs to be configured. The actual process of making those changes is very straightforward. And that's the essentials of making making changes to your cache. Now, once you've made your configuration changes, or when you do your initial configuration change, well, I'll talk about this in a minute when I talk about deploying plugins. So let's go back to some other cache issues. So that's the primary approach to cache configuration. There are two other things you can do. The first is what we call tag-based caching, where you're caching in velocity itself. So you have a page. In that page, you've got a bunch of content, you've got a sidebar, you've got headers, you've got footers, you've got your main content. And you say, oh, this sidebar does not change much at all. We don't change our system navigation very often, or we don't change our footer here very often. So we're gonna, in our velocity template, we're gonna wrap that in this .cache tag. In that .cache tag, we're gonna give it a string, we're gonna call it something, and we're gonna give it time to live. We're gonna say, this can live for 24 hours without getting updated. So that means for the next 24 hours after it's first been hit, every single time someone loads any page that has this template, it's just going to grab this block out of the cache. It's not even going to try and go to the database, regardless of what the content object is. It's just going to grab it out of the cache, which is really great for performance. It's very helpful for regions that don't change a lot. And that goes into that block directive HTML page cache. So when you're using that cache, you might want to keep an eye on this region to make sure you've got it configured to be large enough. The next region of cache, or the next approach to caching, and is a really great performance boost, is every single page has a page cache. So you can go in your index page, look at your properties, and there's a cache right there. By default, every page is cached for 15 seconds. High traffic pages, index page of a website, a really popular subpage, you can go in here, change this to 10 minutes, and get a tremendous performance boost out of that for high traffic websites. Now, what this means is that every single thing on this page is now in cache. Anytime someone hits that page, even if this portion of the page gets edited underneath, so the content, someone comes into the content editor, makes a change to a piece of content, doesn't make a change to the page itself, just to a piece of content, like they edit this image. Well, for the next 10 minutes, it's still going to show that old image. It's still going to show that old content until that page cache times out. even if underlying objects have changed. So if you are making a major change to something on a critical page that's using that page cache, the way you can deal with that is you come in to your maintenance screen and you can flush your page cache. Say, oh, we've just made some changes to really popular pages. We know they're using a page cache. We want to clear those out. You flush the page cache, and it just flushes that region. So when you're going in to flush the cache, and we'll talk about that more when we talk about troubleshooting, you can flush either everything or just certain regions of cache that are being problematic. And so that's the basics of cache tuning. And cache tuning is going to be your biggest performance booster. The next part of configuration we'll talk about is indexes. So the index determines what is and is not viewable on the website. If it's not in the index, nobody can see it. You have to have a live and a working index at all times. Your live index is the publicly viewable website. No one needs to be logged in to see what's in the live index. The working index is all of the live index plus everything that's currently being edited. Something that is being created, something that's being edited, something that's being modified, or something that's in the process of being deleted but hasn't yet been deleted. That all exists in the working directory. It's not unusual to see substantial differences in this count column. You might have 10,000 objects in your live index and 50,000 in your working because you have so many old versions and your site's been up for years. So there's a ton of old content that's still indexed but isn't being shown on the live site. So shards. We use Elasticsearch for our indexes. Shards are how Elasticsearch manages chunks of data. And if you are dealing with a read-heavy system where most of the activity against the index is reading stuff, one shard is the best strategy. If you have a system where you're doing more writing than reading, multiple shards can make sense. The way that dotCMS uses Elasticsearch, one shard is what you really need. Replicas. So Elasticsearch keeps copies of itself, and as you have a cluster, there's going to be multiple nodes, and you want to keep track of what's going on all those nodes. So the number of replicas, which you, if you're doing manual configuration, you'll manually set, and I'll talk about that in a minute. But it's going to be the total of nodes in your cluster minus 1. So if you have 5 nodes, you'll see 4 replicas listed here. In this case, we have 2 nodes, so there's 1 replica listed here. Size is simply how much disk space does this index take up. Now, that's something to be aware of. For performance reasons, you don't want to have a whole bunch of indexes sitting out here. So you're on a reindex, and it's going to run this little thing. Real quick, you get 3 buttons here: stop index, stop and make active, and download failed records. So if you're trying to run a reindex and you run into problems, it doesn't complete, it'll get to like 100% and just hang forever, you can stop the process. You can stop the process and make the new index active if you want. Not generally recommended, but there are some cases where it would make sense. And you can download all the records that failed to index as a CSV file to investigate why they failed. And most commonly what you would do is create a support ticket, attach the CSV file, and one of our developers would work with you to write some SQL that would clean up that problem. As the reindexing process happens, it'll create a new set of live and working. Once the process is complete, it will, if you've got a cluster, it'll copy out to the other nodes in the cluster, and then it will switch over to the new index. and that's where this health comes in. So we have to switch over. It copied over to the other node in the cluster. We can come here and see, okay, so we've got node 1. Here's our IP address. We're running on this port. Store size is 39, which is the two of them combined. 4,200 documents, which is the two of them combined. And we can see both nodes. This master indicator does not dictate that this is the master node of the cluster. It just means that this node is master eligible. And that confuses people sometimes. They think, oh, I've got two masters, something's broken. It just means that that node is master eligible. So the health indicator here can be one of 3 colors. The first of which is going to be green. That's the ideal. Green indicates everything's fine. Yellow indicates a non-critical error. It could mean search is working, but at a degraded performance. It could mean, oh, well, a new node has just joined the cluster and I can't communicate with it yet, or I'm still syncing nodes to this other new node in the cluster, and so it'll show yellow until the nodes in the cluster are in sync. And that's to be expected. Red means you've got a critical error. Your index is broken. One of the ways that can happen, as we talked earlier about having your index on a different partition from your assets, different partition from your dotCMS, if the partition that Elasticsearch is being stored on runs low on disk space, it starts having trouble writing. If it gets below 85% use, so it's got less than 15% free space, it starts to get performance problems. And then eventually, if it runs out of space, it'll actually corrupt your index, and you'll have to delete it and create a new one. So that's, reindexing is pretty straightforward. You can choose to reindex just a particular content type. If you're having trouble, someone has made a change to content, they've hit save, it's not showing up properly. Say, oh, okay, well, let's go into content. We'll just reindex that part of it. Every time someone writes anything, the index gets updated. You don't need to update your index on a regular basis. It's not needed. You can if you want to. It's just unnecessary. So what you would do is you say, okay, well, something happened. You look in the logs, don't necessarily see what the problem is. You can reindex just that particular type of content. It's going to be a lot faster. Like both reindexing and flushing cache are memory intensive. I don't recommend doing them during busy times because there is a performance hit on the site when they are running. So that's something to be aware of. There is an optimize index and a flush ES caches option. The flush ES caches is a new feature. I haven't seen how it functions in the real world yet because 5.0 hasn't even been released yet. But it does look like it's a useful addition to managing performance. Optimize index is not something I've ever really seen anyone use. There's some information at the Elasticsearch site about it, but it's not anything I've seen cause any benefit because we've already done our configuration in management of Elasticsearch to work as well as possible with dotCMS. So I don't think it's really necessary. So that's the essentials of managing the configuration of those items, the cache and the index. There's a couple things you can do with indexes. As I mentioned before, this represents disk space. It also represents performance. So having multiple old indexes, Elasticsearch still has to keep track of those indexes, even if they're not active. So once you have set up a new index, it's been active for a couple of days, well, people have been making edits, people have been making changes, the database is updated. You probably don't want to roll back to the old index anyway because you're going to lose content. So at that point, you want to delete the index because then Elasticsearch doesn't have to manage it anymore. It's not using up disk space. It's going to be optimal to get rid of that. So the next step of if you're doing configuration, we talked earlier about setting up, that's the wrong one, setting up a cluster. So clustering is designed to be used in a single location, a single data center with low latency between the servers. There is a substantial amount of communication between each node in the cluster. If they are located in geographically diverse locations, it will definitely, if it works at all, it will have a negative impact on both the performance and the reliability of your cluster. The only times I've seen anyone try it, it wouldn't even recognize the other nodes in the cluster because the lag was so bad. So it's not recommended. They need to be in the same environment. If you're wanting to do multi-location stuff, that's what push publishing is for. So as I mentioned earlier, I still need that diagram. The requirements for a cluster are your shared database, your shared assets. There will actually be, it's not on the diagram, but there will be a load balancer. And that load balancer will have sticky session turned on because every time, for the duration of a particular session, someone connects to node 1 through the load balancer, they're going to be on node 1 for the entirety of that session. We do not share session information between these nodes. You also have the ability, and it's usually in conjunction with the assets, is to share the dynamic plugin folder. And I'll talk about that a little bit more when I talk about dynamic plugins. So there's two approaches to clustering. There is what's called auto-wire clustering. And I talked about that already when I talked about how you set up your licenses. Auto-wire handles everything for you. You bring up your first node, as I did earlier. You apply your license pack, as we talked about when I was looking at the licensing page. You apply your license to this node. Then you bring up additional nodes that are pointed at the same database, and they will automatically grab their licenses. You don't have any configuration to do it all. In certain situations, you may have a need to do manual clustering. I see not a whole lot of people. When we first introduced this in the 3X series, a lot of people still use manual clustering. A lot fewer people with each 4 release from 4.1 to 4.2 to 4.3. People are just moving away from manual clustering. It's a pain. It's tedious. But we still offer it as an option if it's what you need to do. The situation in which I see it being necessary is ones where there are really strict firewall rules, because auto-wire clustering will pick from a range of ports to run on. We can't predict. You could have an instance running on a certain port. The next time you restart that instance, it may be running its cluster on a different set of ports. So my view of it is, if you have 2 servers that are in the same data center, in the same subnet, and are trusted to each other, you don't need firewall rules between them. If someone has compromised one of your application servers, they have the ability to do whatever they want. They can get into your data, they can change your configuration, they can do whatever they want. Whether or not they can then get to the second node is irrelevant. So I don't see the point of firewall rules between nodes in that kind of configuration, but some people have them. They have corporate rules that require them to do it. I'm not going to change those rules, I know, so we still allow people to do manual clustering. Manual clustering is pretty straightforward. There's nothing complicated about it, but it is a little tedious. So let's bring up an example of And what most people will do is they will simply open up the configuration file, and they will copy in each of these settings and make the adjustments that they need to make. We say we're not auto wiring, we're turning off auto Elasticsearch, but we're still using a cluster. We still are using distributed indexation. We force IPv4 to true. Both Elasticsearch and our caching layers will try to use an IPv6 interface if it's available, which on a lot of servers, particularly in VMs, it can be, but they don't use them particularly well. And it can cause problems for the way that we're using them. So we force it to only use IPv4. We need to use TCP. We need predictability in our networking operations. So UDP can be really handy over long distances. These are nodes that are in the same data center in the same subnet. There's no reason to go with UDP. We'll set the address that this instance is running on, or the port that it's running on. We will also declare not only the address that it's using, but each of the addresses in this cluster. And this is where it gets tedious. You have to do this on every single node in the cluster. If you're making a change to the cluster, if you're adding a node, if you're removing a node, you have to go to every single node in the cluster and edit these host listings. We replicate the same steps for Elasticsearch. Say what port it's going to run on, what IP address we have. And most often people will substitute out the bind address and the network host for environment variables, and they'll just pull it so they don't have to enter those. But you still have to enter it in your list of hosts for both Elasticsearch and for the cache. And this is, as I said earlier, your number of replicas is going to be the number of nodes in your cluster minus 1. So we have to manually set that. So Elasticsearch, by default, enables HTTP access. And I think our documentation needs to change here. I think this should be set to false. That's a huge security risk. It means that anybody who can connect to your server and is aware that you're running Elasticsearch can try and connect to your Elasticsearch directly and make changes to it. There's no security, there's no authentication connecting to this Elasticsearch over HTTP. So disabling the Elasticsearch HTTP is critical in my view. So you'd replicate this process on every node in your cluster. I'm not going to save it, and then you would deploy your plugins. And anytime you need to edit one node in the cluster, you have to take that node down, make your edits, restart it. So if you have 5 nodes in a cluster, you have to go through and make these changes in multiple places. This is very error prone, obviously. The potential for someone typing the wrong thing in the wrong place. You can use something like Chef to automate a lot of it. It's just easier to use AutoWire clustering because in that case, dotCMS handles it all. You don't have to think about it. You can come in and look at your network and get your information and say, okay, looking at server 1, the cluster.22.local IP address 39. Here's my address. Here's what ports I'm running on. I can go over here and look at cluster1.local. Here's my IP address. I can see what ports I'm running on. It's just a lot easier to manage it that way. So as I said, there are certain situations where people still will choose to use the manual configuration, but it's pretty tedious and not really recommended. The other thing that you can configure, and it's just using standard log4j syntax, is logging. And this is actually new in 5.0. We used to break out all of our logging into different files. We've made the decision that As you download it, dotCMS is set up for a developer environment, not a production environment. So we have a single log file for everything. Everything goes into Catalina out. Oops. So everything goes in Catalina out. We don't have any other default logs. There's the Tomcat access log is there, of course, and the other Tomcat logs. If you're wanting to make changes, you would use this log4j2.xml file. And to give you an example of how we would set up, because I'd already set them up ahead of time, say, okay, I want to make changes to this core file. So I'm going to make a new folder in my plugins, root. No, that shouldn't be a problem. Oh, because I did /p or -p. That's why. So I'm going to copy over my original file into this new location. And then I'm going to edit. So in here, you would go in and you would declare what appenders you want to use, what files you want to write to, all of that. As I said, this is new in 5.0, and so we'll have updated documentation on it. We don't really have anything on it at this point. But if you look at the standard, and actually there's an example file here. So we provide an example file, particular properties. We're going to use .cms.log. We're going to roll log files over here. So there's a good example here, which is based on our standard one that we use in our production environments. Once you've made those changes, once you've made any changes to your configuration, really, and we'll talk about what's that? So that is